My name is Nagarjuna, Department of Civil Engineering. I am dealing with structural analysis 1. To the topic is moment distribution level. Problem in the problem is continuous beam. The total span is AB given 5 meters, BC given 4 meters, CD given UDL 3 meters, and DE given 2 meters. Here AB they given the load is 40 kilonewton, DC given 20 kilonewton, and the UDL given 10 kilonewton per meter, and the DE edge load is 10 kilonewton. First we find the fixed end moments. MFAB equal to minus 40 into 3 into 2 square by 5 square equal to minus 19.2 kilonewton per meter. MFBI equal to 40 into 3 square into 2 by 5 square equal to 28.8 kilonewton per meter. Let's find MFBC minus 20 into 4 by 8 equal to minus 10 kilonewton per meter. MFCB equal to 10 kilonewton per meter. MFCD equal to minus 10 into 3 square by 12 equal to minus 7.5 kilonewton per meter. MFDC equal to 7.5 kilonewton per meter. MFDE given a cantilever moment equal to minus 10 into 2 equal to minus 20 kilonewton per meter. Next step is distribution factors. Distribution factor given B, C, E, and B coming members is BA and BC. C given CB and CD, D given DC and DE. Distribution factor K equal to 4E into I by length is 5 equal to 0.8 EA. Next BC 4EI by 4 equal to EI. The coming B sigma K equal to 1.8 EI. Distribution factor K by sigma K 0.8 EI by 1.8 EI equal to 0.444 and BC coming to 0.556 and CV the coming value is EI and CD also coming EI. So find sigma K equal to 2 EI. Distribution factor CV coming 0.5 and CD given 0.5 and BC equal to 4 EI by 3 equal to 1.33 EI. The DE did not given anyone, so we find the 0. Sigma K equal to 1.33 EI. Distribution factor coming BC equal to 1.0. This is moment distribution method, distribution table. Here we have a AB and BC and CD and DE. They are fixed moments. Here B coming fixed moments is BA equal to 0.444 and BC equal to 0.556 and CB equal to 0.5 and CD equal to 0.5 and DC they are 1.0 and D equal to 0. This is fixed moments minus 19.2, 28.8, minus 10, 10, minus 7.5, 7.5, minus 20. Here we have a cantilever moment. So we find 7.5 into 1.0. 7.5 into 1.0. The cantilever moment is 12.5. They coming by 2 equal to 0.6.25. Here next AB span coming to 28.8 into 0.444. The coming value is 19 minus 19.2 into 0.444. The coming value is minus 8.35. by 2 equal to minus 4.18. Here, minus 10 into 10 into 0.5. 10 into 0.556 equal to minus 10.45. Coming by 2 equal to minus 5.23. And 10 into 0.5 equal to 4.38. The coming value is minus 2.19. Same process coming to మనం ఆ ప్రాసెస్ అనేది జీరో వాల్యూస్ వచ్చే వరకు చేయాలి. 0.07 అండ్ 0.09 అండ్ 0.19 0.18 ఇలా జీరోస్ వచ్చే వరకు చేయాలి. జీరోస్ వచ్చాక మనం అన్ని సమ్ చేయాలి. ఏ వాల్యూస్ అన్ని ఒకసారి సమ్ చేయాలి, బి వాల్యూస్ అన్ని ఒకసారి సమ్ చేయాలి. వచ్చిన వాల్యూస్ minus 23.18, 20.91, minus 20.91, 3.14, minus 3.14, 20, minus 20. Next, bending moment diagram. And n moments are developed, tension at top. Free end moment AB given 40 into 3 into 2 by 5 equal to 48 kN per meter. Free moment diagram for span BC is a symmetric triangle with maximum ordinate. The span BC given 20 into 4 by 4 equal to 20 kN per meter. The free end diagram of CD equal to 10 into t square by 8, 11.25. Next problem. They are given moment distribution method. They are photo frame. Here, AB given 4 meters. The load acting on 12 kN per meter for UDL, and same as CD also having 12 kN per meter. They have also UDL. Here BC given two loads, one is 30 kN per meter and 30 kN per meter. The total span is 6 meters. Every 2 meters having 30 kN per meter having load. The load is first we find the fixed moment MFAB minus WL square by 12. They are coming UDL. UDL formula is minus WL square by 12. They are coming minus 12 into 4 square by 12 equal to minus 16 kilonewton per meter. MFBA equal to 16 kilonewton per meter. Here MFBC they given two values, two loads. So we find minus 30 into 2 into 4 square by 4. Here load applying center 2 meters have a span. So we find 4 square. WAB square by L square plus WBA square by 6 square equal to minus 40 kN per meter. Same MFCB equal to 40 kN per meter. MFCD equal to 16 kN per meter. MFDC equal to 16 kN per meter. MFCD also having UDL, so we find minus WL square by 12. Distribution table. Distribution factors. Joint given joint is B and C. B have a members is BA and BC. BA 4EI by 4 equal to EI. BC 4E into 1.5 EI by 6 equal to EI. The sigma K equal to 2EI. The K by sigma K EI by 2EI equal to 0.5. EI by 2EI equal to 0.5. Same as CV 4E into I equal to 1.5 I by 6 equal to EI. CD equal to 4EI by 4 equal to EI. Total 2EI. The distribution factors is 0.5 and 0.5. Next, the moment distribution method. The distribution factors at B equal to 0.5 and 0.5. C also 0.5 and 0.5. Like the moment distribution table, the fixed moment is minus 16, minus 16, minus 40, 40, minus 16, 16. Yeah, 0.5 into 16. Yeah, minus 16 into 0.5 equal to 1. 12, they come in by 2 equal to 6. The minus 40 into minus 40 and by into 0.5 minus what minus 40 minus 16 equal to by 2 is 12. The coming C also 0.5 and 0.5 the coming minus 12 and minus 12 by 2 equal to minus 6. 6 by 2 equal to 3 by 2 equal to 3 minus 6 by 2 equal to minus 3 minus 6 by 2 equal to 3. 3 into 0.5 they coming 1.5. 3 into 0.5 1.5. 3 minus 3 into 0.5 1.5. They have the same problem. They coming the ending values is 0.05, 0.05 minus 0.05 and minus 0.05. The final moments is 8.02 and 31.99 minus 31.99, 31.99 minus 31.99 minus 8.02. The bending moment, the span AB given 12 into 4 square by 8 equal to 24 kilonewton per meter. For B, free and reactions is 30 plus 30 by 2 equal to 30 kilonewton per meter. The coming bending moment diagram. Next, shear force diagram. Here, the shear force diagram, the column AB equal to sigma MB equal to 0. The reaction HA into 4 minus 12 into 4 into 2 plus 31.99 minus 8.02 equal to 0. HA equal to 18 kilonewton per meter. Sigma I equal to 0 gives HB equal to 12 into 4 minus 18 equal to 30 kilonewton per meter. In beam, due to symmetrically IB equal to IC equal to 30 kilonewton per meter. So we find HB equal to 18 kilonewton and HC equal to 30 kilonewton. This is the shear force diagram. And please watching TV stocks and subscribe and follow us.